Hi and welcome to Unit 2, Topic 1, Video 7, Part B. A second example on bearings, and this one is a little bit tougher, so just make sure you take your time getting through the video.
Okay, so example 2, and this one is going to pop up down at the bottom of your screen now. Ben and Georgie. So Ben's walked 12 kilometres on a bearing of 311 degrees true. Georgie's walked 7 kilometres on a bearing of 255 degrees true. Now we want to know how far apart and on what bearing are they away from each other? Or on what bearing is Ben away from Georgie? Now it's important to note here that again we're in a situation where non-right angled trig would probably make this a bit easier, but alas we're going to just move forward and embrace the enjoyment of the question. So let's start with a value here. We've got 311 degrees true and 255. So Ben's this way a little bit, Georgie's this way a little bit. So we're going to do our starting there, A. And Ben goes off in this direction. So I'll have him finish here at B on a 311 degrees true bearing. And Georgie goes off in this direction to point G on a 255 degrees true. Now this angle out here, I don't really care too much about it. So if I pop my little diagram there with north, I can make I'll just extend that out a bit. This is 270, so this angle is 41. And this is 270, so this angle is 15. And in fact, you didn't even have to worry about the 270. 311 minus 255 gives me the whole angle, which is 56. So there's a 56 degree angle there. And I also know this value is 12 and this value is 7. What I need to know is their position relative to each other. So what I'm going to do is, because I've mucked this up a little bit, that 7's out. So Georgie's probably back here a little bit. And I want to know, what does their final triangle look like? It's elongated a little bit. I want to know their final distance, D, and I want to know the final bearing of Ben from Georgie. So this is going to be a little bit tricky to deal with in this diagram. I'm going to have to take out and build another new, less restricted diagram here. But the trick here is going to be to determine how far north of Georgie is Ben and how far west of Georgie is Ben. If I can get those two values, well, I've got a nice right angle triangle, I can get everything from it. Now, of course, if this is north, and I'll do this verbally now, but I'll show you in the diagram I'll draw in a second, then that direction is south, which is 180 degrees. So if I can work out this angle, well then Georgie's bearing from Ben is going to be the leftover from that. And equally, I can work out Ben's direction from Georgie as a back bearing, or something along those lines. There's going to be a variety of different ways I can do it. So in pink, I'll take the diagram out, and I'll draw a little bit of a better diagram. I'm going to start with breaking down Ben's information. That's 12, this is 41, and this is a right angle. And here's how far north and how far west he's travelled. And then I'm going to break down Georgie's information as well, which is going to start here, and it's going to be a little bit smaller. That's a right angle. This is 15, and this is 7. And this is, so I'll call this west G for Georgie, west Ben, north Ben, but this is south Georgie, so that will help me. So there's a bit of interpretation here. So let's first calculate Ben's north and Ben's west. It's meant to be a B, by the way. So his north, this is the hypotenuse, north is the opposite, so we get sine of 41 is equal to north Ben over 12, and therefore north Ben equals 12 sine 41, which is approximately, to two decimal places, 12 sine 41 equal to 7.87 kilometres. And we get cos of 41 is equal to the westerly direction of Ben over 12. So therefore, west Ben equals 12 cos 41. And that's equal to 9.06 approximately kilometres. So there's our Ben information. And then we have our Georgie information. It's going to be a very similar situation. So her southerly distance is opposite. So we've got sine of 15 is equal to SG over 7. So SG equals 7 sine 15, which is equal to 7 sine 15. 1.81 kilometres, and then we have cos of 15 is going to be equal to her West Georgie over 7, so therefore West Georgie equals 7 cos 15, which is equal to 7 cos 15, 6.76 kilometres. So now we've got all the information and we can use it to build a better understanding, because the difference between them in terms of west is going to be the difference between Ben's westerly travel and Georgie's westerly travel. So Ben travelled 9.06 kilometres west, Georgie travelled 6.76 kilometres west. So Georgie travelled to here, Ben travelled to here, 9.06 compared to 6.76. So if I find the difference between them, then we have our total west 9.06 minus 6.76, which is going to be 2.3 kilometres. Now this is all rounded. I'm going to use the actual figures in my final calculation. And then we also want to calculate out how far north Ben is of Georgie. But in this case, if I draw it here, Georgie's gone south 1.81 kilometres, whereas Ben's gone north 7.87 kilometres. And so I need to add those two together. Take the time to add. So north is equal to 7.87 plus 1.81, and that comes out as 9.68 kilometres. And so my new diagram, I am quickly running out of space, my new diagram looks like this, 2.3 and 9.68. So therefore the distance here is going to be a nice Pythagorean relationship. So distance squared will be equal to 2.3 squared plus 9.68 squared, which will equal, and then d will be the square root of that. But keep in mind, I am using exact values. So you get to quietly watch me work on my calculator now and do this calculation. Okay, using my exact values, I get 99, so that's 99, there's no decimal point there, let me rub it out. 0.06, and the square root of that, still on exact, is 9.95 kilometres. They are 9.95 kilometres apart after they've both gone off in their walks in different directions. The second part of the question is to do with the bearing. Now, I've run out of space, but I really want to keep it all on one board. This is a little bit problematic for me, but I'm going to aid this by working in this little space here. And I'll use a different colour to make it maybe better. So this is now the worst video ever. So I want to find this angle. If I can find that angle, then I know this angle. And if I know this angle, then I can work out the bearing by taking it away from 360. So take some time to have a think about that. And excuse me if I use up the space really poorly, but I might just draw a better diagram. So that's that, 9.68, 2.3, and there's my theta. And so I'm going to work on tan theta is equal to 2.3 over 9.68. So therefore theta is equal to tan inverse of that. And you're going to have to watch me as I use exact values again. And tan inverse of that with exact values is 13.33 degrees. So therefore, if this is 13.33 degrees, then this is 13.33 degrees. And the bearing is equal to 360 minus 13.33, which is equal to 346.67 degrees true. So, what I'm going to do now is I'm going to rub this off, and then I'm going to peer back in your faces with a bigger, better diagram. All the working will be gone, but you can obviously rewind to see the working, and I'll use that bigger, better diagram to summarise the answers. Here's the diagram. That was magic. So, there's my first diagram. This is Ben's walk. This is Georgie's walk. We knew 12, 41, 15, 7. And then we calculated, using a bit of right angle trig, Georgie's westerly distance, 6.76. Georgie's southerly distance, 1.81. Ben's westerly distance, 9.06. Ben's northerly distance, 7.87. And then from that, we could work out the total distance between them in the north-south direction, the total distance between them in east-west direction. We did this one by subtraction, this one by addition, because we had to interpret what was going on. And we get 2.3 and 9.68. Then we jumped into this nice right angle triangle here, which is their final positions compared to each other rather than compared to a start point. And we used a bit of Pythagoras to get 9.95 as the distance between them. And then we used a bit of right angle trig to calculate this angle up here as 13.33. And we reversed that down into here. And then we subtracted from 360 to work out this overall bearing, which is the bearing that Georgie would have to walk to get to Ben. In fact, we can now say to Georgie, if you want to get to Ben, you've got to walk 9.95 kilometres on this bearing, and that bearing was 346.67 degrees true. Or we could say to Ben, if you want to get to Georgie, you've got to walk 9.95 kilometres in the opposite, as a back bearing, which would be this minus 180, 166.67. So that was a pretty tough question, but realistically, a good diagram, and anybody can do that question.
Well, I hope that made sense. Of course, take some time to review it, come back in a week's time, try the question again, and then reconfirm your understanding through this video. All the best.